Hello, everyone. I hope that you've had a good week this week. Today, we need to start learning how to solve quadratic equations by factoring. And so that's what this video is going to be focused on. So hopefully you've seen a quadratic equation before. So a quadratic function. And if you recall from earlier in the semester, I prefer to write functions abbreviated as FCT. So you might see that sometimes, just as a little reminder. And a quadratic function is the standard form of that function is always going to be y equals ax squared plus bx plus c. And when you graph a quadratic, hopefully you remember from Algebra 1 a little bit that when you graph a quadratic, you get a parabola. So you can have an upwards facing parabola or a downward facing parabola. And anytime you graph a degree 2 function, you're going to end up with a parabola. So when we graph our parabolas, as you can see on this graph right here, this parabola has been graphed on this coordinate plane. This parabola hits the x-axis twice. So do you remember what we call those points where a graph hits the x-axis of the coordinate plane? We call those points the x-intercepts. So these are both x-intercepts. So when we're solving a quadratic function, what we're actually solving for are the x-intercepts. So to solve a quadratic function, what I'm really telling you to do is find the x-intercepts. So when you solve a quadratic function, I'm really asking you to find the x-intercepts. And that's something that you want to have memorized. When you see solve the quadratic equation, your brain needs to think of find the x-intercepts. So when I talk about an x-intercept, both of these points here, so it looks like this first point is at 3, 0, and the second x-intercept is at 5, 6, 0. What do these 2 points have in common? What these 2 points have in common is that the y value of these points is 0. So whenever you have an x-intercept, you're always going to have a point that has some x value, but the y value is always going to be 0. Y is always 0. So because the y value is always 0, we can actually refer to these x-intercepts as zeros. So x-intercepts are also known as zeros. So as you can see in this picture that I shared with you, when you have the zeros, when you have the x-intercepts here labeled, it also refers to the x-intercepts as the zeros of the function. And the reason why it's called a zero is because it makes the function equal 0, or it makes the y value 0. So why do we call x-intercepts zeros? Because these x values will always make the function or y equal 0. So for example, if we talk about the parabola that was graphed in this example for us with the x-intercepts 3, 0 and 6, 0, the equation of that parabola is y is equal to x squared minus 9x plus 18. Now, remember the x-intercepts that we found on this graph are the points 3, 0, and 6, 0. So the x-intercepts are 3, 0, and 6, 0. If I plug in the x value, x equals 3, into this equation, what do you think it's going to give us for y? Well, let's see if you're correct. So let's do y is equal to 3 squared minus 9 times 3 plus 18. Y is equal to 9 minus 27 plus 18. Let's see, y is equal to 9 plus 18 would be 27, minus 27 is 0. Hey, check it out. We got, when x is 3, what is y? 0, which makes sense, right? Because that point was 3, 0. The point has an x value of 3, a y value of 0. Now let's try the other x value from the second x-intercept. X equals 6. So when I plug this into my equation, y is equal to 6 squared minus 9 times 6 plus 18. I'm going to switch to purple. Y is equal to 36 minus 54 plus 18. And when you add that all up and subtract the 54, you should end up with 0. Well, check it out. Y is equal to 0 when x is 6. Does that match the point? The x value is 6, the y value is 0. So what did these x-intercepts, or these x values, give us in the equation for y? 0. They made the equation equal to 0. So what else can I call an x-intercept? Zeros. So x-intercepts and zeros are the same thing. They're the x values that make the equation equal 0, and you can find them on the x-axis of the graph of the parabola. So now let's get into the meat of this lesson. So we're going to learn how to find those x-intercepts by factoring quadratic equations. So when I say to solve quadratic equations, what am I really asking for? I'm really asking you to find the x-intercepts. And what else can we call the x-intercepts? They're also known as the zeros. Find the zeros of the equation. So I've got 4 super duper easy to follow steps for you for solving quadratic equations. And these steps should work every single time. So step 1 is to set the equation equal to 0. You always want to use y equals 0. When you're trying to find the x-intercept, what is the y value of every x-intercept ever in existence in this world? 0. So we always want to use y equals 0, and we want to make sure the equation is equal to 0. Step 2 is to factor the equation. Step 3, you are going to set each factor equal to 0 and solve for x. So that's how we're going to find our x values. We're going to set each factor equal to 0, and we're going to solve for x. Then step 4 is to write your final answer and check it. Make sure you're correct. All right, so let's use those 4 super duper easy to follow steps and apply it to our very first equation. So our first example is y is equal to x squared plus 2x. Step 1, set the equation equal to 0, or use y equals 0. So we want to replace y with 0 equals x squared plus 2x. Step 2, factor. So when I look at x squared plus 2x, I only have two terms, and I want to see if they have a greatest common factor. Well, x squared and 2x have a greatest common factor of x, so I'm going to factor that out. And then I'm going to have left x plus 2. And I know that's right because x times x is x squared, x times 2 is 2x. Now we're ready for step 3. Set each factor equal to 0 and solve for x. So I'm going to set this first factor, which is x, equal to 0. Then I'm going to take the second factor, x plus 2, and set it equal to 0. And now we need to solve for x. So we have the equation x equals 0 and x plus 2 equals 0. Well, in x equals 0, x is already isolated, so we know that's one of our answers. We're done with that. In the second equation, x plus 2 equals 0, we need to solve for x. So I'm going to subtract 2 to both sides. And I get x is equal to 2 minus 2 cancels, and then 0 minus 2 is negative 2. So I have two solutions. I have two x values, or two x-intercepts. And they are x is equal to 0 and negative 2. Now, when you write your answer on Delta Math, when you do your homework and you do your answer on Delta Math, for Delta Math, they already give you x equals in the answer box, and then you have to type in, you would type in 0, comma, negative 2. So make sure when you do Delta Math that you do your answer correctly, because they're a little picky about how you type it in. So what I'd like to do for this problem is make sure that we're correct. So the cool thing about solving quadratic equations is that you can go back and make sure every single answer is correct before you turn it in. So you can get 100% on all of these assignments because they're all easy to check. So remember, what we found were zeros, which means that x equals 0 and x equals negative 2 should make our original equation equal to 0. So let's see if that works. Y is equal to x squared plus 2x. Let's plug in 0 first. So 0 squared plus 2 times 0. Y is equal to 0 plus 0. Y equals 0. That checks out. Next, we need to check negative 2. So now we're going to plug in negative 2 for our x values, and we get y is equal to negative 2 squared plus 2 times negative 2. Notice I put negative 2 in parentheses because I want to make sure that I square that negative. So y is equal to negative 2 squared is positive 4, plus 2 times negative 2 is negative 4. Well, 4 minus 4 is 0, and that one also checks out. So we know that the answers x equals 0 and negative 2 are in fact correct. So I want you to go ahead and try part B on your own. Pause this video and then unpause it when you're ready to check your answer. Go for it. All right, so let's check part B. So for part B, our first step, set y equal to 0. Make the equation equal to 0. So 0 equals 2x squared plus 4x. Step 2, factor. So your GCF of 2x squared and 4x is 2x, and that leaves you with x plus 2. So your factored form is 2x times x plus 2. Next, you should have set each factor equal to 0. So you're going to set 2x equal to 0, and you're going to set x plus 2 equal to 0. So this got set equal to 0, and this got set equal to 0. Solve for x in both. So divide by 2. X equals 0 divided by 2 is 0. And then subtract 2. X equals negative 2. So your answers are x equals 0 and negative 2. All right, let's do part C together. So part C, again, step 1, you want to make sure this thing is equal to 0. So 0 is equal to x squared plus 3x plus 2. Step 2, factor. Well, the only factors of 2 are 2 and 1, and I know x times x is x squared. I would need a positive 2 when I multiply and a positive 3 when I add. So I want both 2 and 1 to be positive. Step 3, set each factor equal to 0. So set x plus 2 equal to 0 and x plus 1 equal to 0. And then solve for x. So subtract 2 to both sides. X equals -2. Subtract 1 to both sides. X equals -1. So our answers are x equals -2 and -1. And if you wanted to make sure that these are correct, just go back, plug both answers into the original equation, make sure they make y equal 0. All right, so part D. So before you try part D by yourself, you're going to notice that part D doesn't actually have a y in it. In fact, it says 48 plus 8x is equal to x squared. Well, we need to make sure that this is equal to 0 before we try to solve it. So what I suggest you do is move the positive 48 to the other side by subtracting it, and also move the negative 8x to the other side by subtracting it. So we're going to have 48 minus 48 cancels, 8x minus 8x cancels, so what are we left on this side? 0 is equal to x squared minus 8x minus 48. So I went ahead and put 48 and 8x in standard form. So it's ready to go. So now go ahead and pause the video, factor this thing, solve it, give it a shot on your own, and press play when you're ready to check your answer. All right. So when you factor this, you should have 0 is equal to, let's see, what are my factors of 48? 1 and 48, 2 and 24, 3 and 16, 4 and 12. Let's see, 4 and 12 should get us -8. So let's try that. X times x, 4 times 12. 1 and negative when I multiply, a negative when I add. So I'm going to make 12 negative and 4 positive. Then set each factor equal to 0 and solve for x. So x equals -4 and x equals positive 12. You would subtract 4 to both sides. You would add 12 to both sides. So your final answer should have been x equals -4 and 12. All right, let's do part E. So again, in part E, we have 144 equals x squared. We need this equation to be equal to 0 before we can solve it. So I'm just going to subtract 144 to both sides. And that's going to leave me with 0 on that left side, and then x squared minus 144. Well, hey, x squared minus 144 is a difference of squares. So that means I can factor it as x times x is x squared, 12 times 12 is 144, and then what signs do we need so the middle terms will cancel? One needs to be positive, one needs to be negative. So then x plus 12 equals 0, and x minus 12 equals 0. So subtract 12 to both sides, x equals -12. Add 12 to both sides, x equals positive 12. So now, when you write your final answer for this, because these are the same number and one's positive and one's negative, you can either write it as x equals 12 and -12, or if you're feeling fancy, you can write it as x equals plus or minus 12. And that just tells me that positive 12 is one of the answers, and so is -12. Now, go ahead and give part F a shot without me. Press pause, and then press play when you're ready to check your work. So your very first step should have been to subtract 100 from both sides. X squared minus 100 is equal to 0. You have a difference of squares, so x plus 10 times x minus 10 is the factored form. Set each factor equal to 0. Then solve for x. So subtract 10 to both sides. Add 10 to both sides. And I'm feeling fancy, so I'm going to write my final answer as x equals plus or minus 10. And there we go. I hope you guys have a good weekend.